In this video, we're going to do a comparison between these two superficially similar looking circuits. If we trace the pathway of the current through the first circuit, we can see the anode is on the bottom of the battery here, meaning that our electrons are going to flow counterclockwise through this first light bulb, passing around through the second, and then through the third, and back around to the cathode like this. Now, as a thought experiment, let's say that the filament, which is the wire inside of the light bulb that not only passes electrons through it, but causes the light bulb to light up, let's say that this filament burns out, meaning the first light bulb doesn't work. If this were to happen, what would happen to the second and third bulbs? Would these bulbs still be lit? Well, if the filament is burned out, that means that the electrons from before this light bulb are unable to cross because the filament in the light bulb also acts as a connecting wire, and therefore our circuit is no longer complete. So if these electrons are not able to get past the first light bulb, they won't be able to get to the second or the third light bulbs, and both of these would not be lit. This circuit is what we call a series circuit because each of the loads within the circuit are arranged one after the other, which is what we call consecutive or consecutively arranged. Now, because these loads are arranged one after another on the same circuit, if one of these light bulbs were to burn out, that causes the entire circuit to be broken, meaning that none of the other loads after the original one that burned out would be able to work either. So what can we do in order to correct this limitation? Well, if we take a look at the circuit on the right, we can see that it's actually three separate circuits in one. So if we trace a pathway for the current for the first light bulb, we see that it forms a complete circuit on the inside here. But if we trace the current for the second light bulb, we see that this current only shares a partial pathway with the current for the first light bulb because these two light bulbs are technically on separate circuits from each other, and the same also applies for the third light bulb on the outside. So let's do the same thought experiment. Let's say that our first light bulb here burns out. Would this burning out of the first light bulb affect the second or the third light bulbs in the circuit? Well, as we've seen, the current pathway for each of the light bulbs is different, which means the burning out of the first light bulb does not affect the circuit for the second or the third light bulb because they operate independently of each other, and therefore, unlike the circuit on the left, these light bulbs would be able to stay lit even if one of them burned out. Now, because these light bulbs are not arranged in series, this is what we call a parallel circuit. Because, again, each of these loads are effectively placed in separate circuits so that the burning out of one light bulb is not going to affect any of the others, meaning that the burning out of a light bulb only causes one of the circuits to be broken, allowing the other ones to operate independently. Now, this gives us a natural advantage of organization in parallel because the failure of one of our loads in this circuit is not going to affect the other two loads. Now, as for why we don't arrange every circuit in parallel, we can see in terms of the length of wire that we need to construct a series circuit versus a parallel circuit, you can see that we need much less electrical wiring in order to create a series circuit compared to a parallel circuit. This concludes our videos on electrical circuits as practice to see whether you can identify and understand the difference between series and parallel circuits, take a look at the two circuits below. Your task is to identify which of these circuits is arranged in series, which of them is arranged in parallel, and see if you can represent each of these circuits using circuit notation in the spaces below.